Hello everyone, I hope you all are doing great. So today we'll be starting the lecture on operations of the junctions, operation of the transistor, how a transistor actually works. So before delving into the details that how transistor work, I want you to first note down few things. You all may know the concept of forward biasing and backward biasing, and you all, if you have seen my previous lecture where I taught you about the basic structure, how a transistor look like, what is the basic functionality and basic structure of a transistor. So in that video, I told you that transistor is combination of two junctions. That means two types of processes are going on in transistor at one time. So we do have variations of the biasing. Like if in a case we are considering this part, so may be possible that there is going on forward biasing here, or maybe a reverse biasing here. If we consider this part, so may be possible there is going on forward biasing, or maybe a reverse biasing. Well, by the variation of combination of these four possibilities, we get the four functionalities of a transistor. A transistor can work as an amplifier if in a situation this type, this section of the what we could say the transistor in the NPN junction or PNP junction. PNP junction. These are two types of the transistor that we do have. So if in a situation this side, the emitter and base side is having forward biasing, and the base and collector side is having the reverse biasing. So in that case, the transistor act as an amplifier. What is an amplifier? An amplifier is a device which works on the working of increasing the frequency of this thing. Most of the time amplifiers are attached within our speakers just to increase the voice of the soundtrack of the speakers. So yeah, that's the functionality of the transistor. Well, in second case, if in a situation where the forward biasing is going on in the same thing in the side of the emitter base junction, but the side of the base collector junction is having again a forward biasing. Both are having the forward biasing. So in that case, the transistor will become a switch, and this switch would be a switch on button. Since I maybe told, yeah, I told you in my previous lecture that a transistor can work as a switch as well. So if the forward biasing is going on in the both of the type of junction, so in that case it works as a switch that is on. Just opposite of that, if both of the junctions are having reverse biasing, so in that case it works as a switch, but this switch is off. Okay. Well, if in a situation we are having reverse biasing in the emitter base collector, emitter base junction, and we are having the forward biasing in the side of the collector and base junction, so that case, that system is known as cutoff section, cutoff junction. That's a such a cutoff is actually a place where neither the current is flowing, neither the electrons are flowing on. So that's the case. One more thing that you must know is that conventional current is the application, it's the function, or it's the type of current that flows in the transistor. What is a conventional current? Just suppose that I am attaching this potential in this system, and I'm actually, let's say here I do have a resistor. It can be a bulb, it can be a device, it can be anything. Resistance can be created by any of the device as well. Now in this case, if we talk about the current, I'm talking about I, the current. So the current always flows from the positive terminal to the negative terminal. But we all know, as in the transistor, we don't attach a sort of source, a sort of direct source. We attach a battery. Either we attach a cell. What's the difference between a battery? Battery is actually a high potential. It is shown by this symbol, while the cell is of low potential and it is showcased by this symbol. Well, that's a different thing. So in the battery or a cell, the current flows from the electrons actually flow, not the current. The electrons flow from negative terminal to the positive terminal. So here in the case of conventional current, whensoever you hear the word conventional, so this concept of opposition must be in your head, that the flow of electrons and the current is opposite in the case of conventional current. Well, it's not an in-depth thing, neither it is so much highlighted in our textbook, so we can just consider it for the equation derivation, or if further its application are there, so we would need to focus on this factor of opposition in further topics, not for now. For now, let's start the operation of the current. Let's first consider the NPN junction. Well, it's not a big case if you are considering NPN junction or either PNP junction, since most of the time the mobility of the NPN junction is considered as more and the mobility of PNP junction is less than NPN. So we most of the time use NPN junction in our daily routine or in most of the appliances. That's why we mostly study the NPN junction as an example. We all know what's the symbol of the NPN junction. So here, this is a symbol where this is considered as a base, while we do have two of the lines going on. This one is emitter, this one is collector, and we do have a arrow going outwards in the case of NPN junction. So this is the symbol of the NPN junction, NPN transistor. So let's draw this out. So for the consideration, let's say that this is a let's consider, let's first draw a simple diagram, then I'll say, okay, now this is what, this is a emitter, this is a collector, and this is the base. Now in the case of the emitter and base junction, we always attach a cell with it, low potential. And in the case of the base and collector version, we always attach a battery with it. Now here, if you'll see the potential system, the attachment of the potentials direction or polarity, I have actually attached the negative terminal here and positive terminal in this case, and here negative terminal, and this one is positive terminal. Since this negative terminal is attached, again this is an NPN junction, right? So if negative terminal is again attached with a negative terminal, so in that case this scenario will cover the forward biasing side, while in this case I have attached the negative terminal with the holes, so terminal to the N side, so it becomes reverse bias. Now these two things are, hope so it's clear to you. Now in the case where the forward biasing is going on, we all know that because of the forward biasing, the depletion layer, if we just consider this side, in the forward biasing, the depletion layer of the NP junction is really thin, that it now, after when we'll start giving potential, this depletion line won't exist anymore in the case of forward biasing, just because of the flow of current. And since we are having holes here, so the electrons will easily get attracted towards the hole. So this is the basic reason that we do call this NPN junction as the this transistor word. If you have seen my video, so in the starting, when I was giving the introduction of transistor, I highlighted this thing that transistor is derived from two terms: trans, which means transfer, R, sister, means the resistor. The transistor is the transfer of the resistance. Now, because of the reverse biasing, we know this thing that here the depletion layer would get approximately zero, and this depletion layer will somehow transfer to the reverse biasing side, the another junction side. So this transfer of resistance make it a transistor. This was the basic. I hope that the process of forward biasing and reverse biasing is clear to you. Now we'll move on to providing the potential and what will happen when we'll provide the potential to the system. So here I'll redraw the whole system once again, but along with the providing the system to it, or you could say that by the help of the symbols I'll make it. So this side is known as a emitter. Okay, this side is a collector. That means this side is actually attached, this side is attached with a battery. Here I've attached it with a battery. This is N type, so the positive terminal will be attached with this side. And this is attached with a cell, and the negative terminal stays here. So this becomes a forward biasing. Again, we do have a base as well. This is the base, and base is attached by both of the junctions. So this is the basic the diagram. If in a case you are given this diagram, so you must know that how the things are going on. Same thing if we'll draw on the junction that we are studying since so far. So here it will be something like this. This is the section that is highly doped. Highly doped, I've told you about the concept of doping in my previous lecture. That what is a doping? This side is relatively less doped and this is the least doped. Well, what we did, we attached a cell here, negative side, and this is the positive side. This is the base. That's what we actually draw here as well. So this will be a negative, positive, negative, and positive. Now let's start providing the potential. Let's say that we are providing current. We start forward biasing first, and we are providing current from this end. So here the flow of electron is in this direction, so we know this fact that current, let's just not consider the current first, let's consider the voltage here. So the voltage provided by the emitter and base is can be considered as VBC. Oh, not VBC, VBE. And this potential can be considered as VBC. Okay. Now, the current is flowing in this direction. So electrons will start flowing and they will get attracted towards the holes. And again, the flow of current would be in this direction. And the electrons will start moving in this case. Now, one thing that you need to focus on is the leakage electrons or leakage current, that is the current that we actually drop down in the side of the base. Let's just consider the electrons that are moving from the negative terminal to the positive terminal as N. Now because of the leakage current, we got an sort of decrease in the current. Let's consider that decrease in the current. Let me just change the color. Let's consider that decrease in the current as 1 minus A. and let's say that this is being multiplied by n. This alpha, this A represents us what? This represents the drop down of the current that was actually happening. And let's say that the electrons after the leakage current actually reach this collector side is the alpha n. Okay, so these three things I have written here, that we got n, that was in what? Emitter. Then we got alpha n, that was there where it was in the collector. And then we got 1 minus a alpha into n, that was where in the base. Now there is a specific percentage of the alpha, by the way. We only get 1 to 2%, 1 to 5%, or you could say 2 to 5% drop down, and 95 to 98% of the electrons reach out this side. So we could say this fact that only 2% to 5% is considered as the alpha. So all the time the value of the alpha is actually, in the case of this whole scenario, it's always less than the 1. Okay, like if we are providing 100 electrons, so at that side, in the collector side, 99% electrons will reach out. So in that case, if you'll divide, let's just not consider that things, and since to take out our percentage, alpha is considered as the electrons in the emitter divided by the electrons, no, electrons in the collector divided by the electrons in the emitter. So 99 divided by 100 is something like 0.999. So this is less than 1. So that's how we get the concept that alpha has 1%, 2% to 5%. Well, now let's just get back to the actual situation, get back to the actual scenario where we were. Okay, we got two behind. This is an extensive thing. Well, now let's talk about the current that is flowing in the whole system. Let me just remove these so I could have some space to make point out other things. Okay. Okay. Now, we all know that the flow of current is in that direction, in this direction, right? So we all know that in the starting I told you that what is conventional current, that is opposite in the direction of the electrons. So the current that is flowing would be in direction of this, in this direction. Let's just consider that the current that is flowing in the direction or in the emitter is IE. That is the current in the emitter. This is IE. The current that is dropped into the base is IB. So IB is the current that was dropped into the base. And third type of current is IC, which is the current that actually reached the source, that actually get generated by the flow of current that at the end reached out the um, base collector side. Because of the reverse biasing, the collector generated an current that is IC. Now we all know that the electrons started flowing from the IE, from the emitter side. So the maximum current is at the emitter. The minimum current is at the base, since only there the flow of current from the base side is only 2% to 5%. And somehow we could say that if we add the IB and the IC so we can get the actual number of current that was flowing. 2% the current start flowing from IE, 2% to 5% dropped here, and 95 to 98% reached out the IC side, the collector side. So if we add on that 2% to 5% into the 95 into 98%, so we'll get the actual 100% IE. So from here, the concept of IE is equal to IB into IC comes out. And this is the equation of this lecture. This is the most important equation that you need to keep in mind just in case to study the operation of the current. From tomorrow, we'll get into the more depth, and we'll get into how this IB is in relation of alpha, how this IB is reacting with electrons. So this thing we'll cover in upcoming video. For now, thank you so much for watching, and stay tuned for the future videos.